Let's talk about the terrestrial planets. So these are, let's see, what are the terrestrial planets? The terrestrial planets are Mercury, Venus, the Earth, Mars. Sometimes we throw in the Moon as well, because it's, I mean, it's not a planet in and of itself, but it's a terrestrial object, made of similar sort of stuff, same sort of place. So we can throw these together. So let's take a look at these things. In bulk, they're very, very similar. You know, they're made of the same stuff. They're made of rocks and metals. They have mountains and valleys and craters, and they're formed in the same part of the solar system at the same time. They're all made of rocks and metals because, you know, when the solar system was first forming, to make planets, you got to start with solid materials. Near the sun, it's hot. So what's solid? Rocks and metals. So you get planets which are dominated by rocks and metals. However, when we start looking at these objects in more detail, they're very, very different. For instance, Mercury is just totally covered with craters. Craters all over the place. Look at Venus. Very few craters, only a couple. Few craters. Same deal with the Earth. I mean, there's a couple of craters. There's Barringer Meteor Crater down in Arizona, a few others, but relatively few. Nothing like Mercury, so few craters. Look at Mars. Mars has a lot more craters, not as much as Mercury. Mercury's pretty much saturated with craters. Craters everywhere. Mars has lots. The Mercury's craters totally. Then you look at the Moon, and the Moon is a lot like Mercury. You look at the surface of the Moon, the surface of Mercury, and they're both, you know, tons and tons of craters. There's you know, lots, tons of craters over most of the Moon. So why? Why would that be? Why would we end up with huge numbers of craters covering Mercury, most of the Moon, lots of them on Mars, not so many on the Earth and Venus? What's going on here? Why is that? Well, in order to explain that, the key idea is that craters are what happen to a surface when nothing happens to a surface. How do you make a crater? Big rock comes flying around through space, smashes into the object, makes a big hole in it, and there you go, that's a crater. And there's rocks in space. There's always rocks in space. There's always things floating around in space, smashing into planets. There were more at the beginning of the solar system, there are less now, but it's constantly happening. It's an ongoing process. So, if you've got nothing else going on in on your planet other than, you know, well, nothing else going on, then eventually it's just going to get covered with craters. So when we look at a planet and we see not so many craters, that means other things are going on here. There's some other process going on. Mercury has nothing going on there. Nothing's happening on Mercury. It's hot, there are craters, rocks hit it from space, end of story. Venus, on the other hand, what's going on with Venus? Venus is interesting. Wow, why does it have fewer craters? Well, Venus has active volcanoes. And so those active volcanoes, when a volcano erupts, you know, it spews out lava, it covers over the craters. And so then you end up with, you know, covering the craters, and so you don't have as many craters. On the Earth, well, we got all kinds of process. We have the volcanoes, just like Venus. And plus, we have other things. We got weather, we have erosion, we have plate tectonics. Weather, plate tectonics. All of which are processes which act to cover up craters. Okay, cool, so that's good. Mars, well, what's the deal with Mars? Mars used to have active volcanoes. There was a time in the distant past where it had an amazing volcano. The Olympus Mons was an active volcano on Mars in the distant past. Olympus Mons is the biggest volcano in the solar system. It's 3 times as tall as Mount Everest. It's a huge, giant shield volcano. But it's also been dead for billions of years. It had volcanoes for a while. Mars had volcanoes for a while, then, you know, then not so much now. And so maybe the first billion years or so while it was around. And so that's why, okay, there's some places on Mars where you got tons of craters, and others were covered over by activity at one point or another. Mars also has an atmosphere. Mercury has basically no atmosphere at all, but Mars has some atmosphere, so, you know, there can be some erosion and things going on there. The Moon, yeah, very similar to Mercury, no volcanoes. Not for a very, very long time. And so that kind of explains it. The existence of whether you have craters on a surface or not on a surface of these terrestrial objects can be explained by whether you have volcanoes or not. But that only pushes the question back to that step. Why do some of these guys have active volcanoes today? Why is it that Mars had volcanoes for a while? Mercury, I don't know if it ever had volcanoes. It was very trivial and very long ago. How come? Why do these have volcanoes today? Mercury, maybe almost never. Mars, only in the distant past. Again, the Moon in the very distant past. Why? You got these 1, 2, 3, 4, 5 objects, 5 terrestrial objects that formed in the same place at the same time out of the same stuff, yet the Earth and Venus have volcanoes erupting. Today, the other planets don't. Okay? What do you got to do to have volcanoes? Well, you got to have this nice, molten, liquid, chewy center sort of thing like this. You got to have a lot of heat inside and liquid rock and magma on the inside of you so that can break through the surface in different points and then be a volcano. If you cool off on the interior and are solid all the way through, well then you're not going to have active volcanoes. Here's the thing. I got a question for you. Suppose I'm roasting a turkey and a chicken in the oven, and they both roast and they get up to temperature and they're in there for hours and hours, and then I take them both out at the same time, set them on the counter, and then I go away for a couple hours and I come back. Which one's going to be hotter? The turkey's going to be hotter because it's bigger. Big things take longer to cool off. The chicken will be cooler because small things cool off more quickly. General principle of heat and stuff in our universe. And this pattern of these volcanoes and all this sort of stuff is all about size. The Earth is the biggest of the terrestrial planets. Venus is almost the size of the Earth, pretty close. So because they're both so big, then they have very hot molten interiors. Mars is kind of mid-sized, and so what's the deal with Mars? So Mars was active volcanoes for a while and then cooled off. And Mercury and the Moon are both small, quite a bit smaller than Mars, and so they cooled off very quickly. And so that's a wonderful thing. That explains it. So if you cool off very quickly, then your volcanism, volcanic eruptions is going to go away amazingly fast, and there you go. That's going to explain it. Whether we have craters or not, it really has to do with size. If there was another planet, the size of Earth or bigger, another terrestrial object around here, it would not have craters on it because it would still have active volcanoes. So the bigger you are, the longer it takes to cool off. And where did they get hot in the first place? Well, everything started out hot at the beginning. Because remember, when you got things forming, you get your little dust bunnies, and then bigger sizes, and gravity starts pulling things in, and you got objects the size of mountains, and then continents smashing into each other, and so that's tons of energy. So all of these terrestrial objects started out as hot blobs of molten lava orbiting around the sun, and then first the crust cools off, and you form a crust, surrounded this molten center, and then as time goes on, the crust thickens, and more stuff gets more and more solid. And the Earth has tons of solid in there. It's not just like the Earth is, total lava in the inside, but it has substantial amounts of liquid rock in there. And so that explains it. Here's another big issue. Atmospheres. Mercury, basically none. Venus, tons of atmosphere. Venus has 95 times more atmosphere than we do. Earth has lots. Mars, very little atmosphere, very thin atmosphere. It's about 2% as thick as ours. 2% of us. And then, of course, the Moon has basically none. Okay, so, again, why? Here are 5 terrestrial objects. They formed together at the same place in the same time out of the same stuff. Why would some of them have atmospheres? Why would some of them have air? Earth and Venus have lots of air. Mars has some. Mercury and the Moon have none. And hey, I've seen this pattern before. Okay, you know what's going on? I mean, the question is, where does air come from? Right now, we're breathing air in and out. I ask, okay, you're breathing air right now. It's mostly nitrogen, a substantial amount of oxygen. Where'd the stuff come from? And the first person says, well, it's the plants. They put out the oxygen, and even nitrogen kind of circles around. I'm like, okay, yeah. But originally, the plants and these other things, they reprocess these from one gas to another. But the real question is, where did the gases come originally? Where does air come from to begin with? And air originally comes from volcanoes. There are several sources, but a really big, huge, giant, important one is volcanic outgassing. When a volcano erupts, it puts out lava, molten rock, it puts out ash, it puts out all these sorts of things. And you know what else it puts out? Huge quantities of vast amounts of gas, lots and lots and lots of gas pouring out of volcanoes all the time. Even when they're not erupting, you go around near a volcano and, there's bubbling stuff and there's gas coming out of that. Volcanoes give out lots and lots of gas. And this explains the atmospheres as well. Check this out. Okay, so the Earth and Venus both have active volcanoes erupting today, and so they both have substantial atmospheres. Mars had some active volcanoes for a while, for a substantial part of its history, maybe 1 billion years or so. It had active volcanoes, built Olympus Mons, 3 times as tall as Mount Everest. It's a heck of a volcano. And so even today, it's still got, 2% of the Earth's atmosphere still hanging on there. And then you look at the Moon and Mercury, and well, they had trivial volcanism for a very short period of time. So they don't have very nice atmospheres. Cool. Let's look even more specifically at the Earth, Venus, and Mars. Let's focus in on these guys, because this is really interesting. The Earth is a nice place to visit. You should go there. It's a lovely place to see. Venus is horrible. Venus is awful. Venus is a nasty, ridiculously bad place. If you were to beam down onto the surface of Venus, you would be instantly killed in 3 fascinating ways. First of all, you would be crushed by the pressure, the 95 atmospheres, pressure. Oh, you would be burned alive by the heat because it's hot enough on the surface of Venus to melt lead, crazy super hot. Oh, and then, by the way, while you're being crushed and burned, Venus is covered with all these big, nice, fluffy clouds made of sulfuric acid, so they would be poisoned by all of that. Why? The Earth and Venus are similar sizes. They have similar atmospheres. They have similar volcanoes. Volcanoes produce atmospheres. What's the deal with that? Where did they come from? Why is it that the Earth and Venus are such crazy, enormously, fantastically different places? The reason why they're okay. So of the two, the weird one is not Venus. It's us. Venus, if you take that atmosphere, it's basically 4.5 billion years of volcanic eruptions. Billion years of volcanoes. If you just add up the gases coming out of a volcano for 4.5 billion years, that's the atmosphere you get. Venus basically has, 4.5 billion years of just volcanoes erupting gas, and there it is. It's still there. The weird one is the Earth. We got all this nitrogen and oxygen. Where did that come from? What's the story on that? So the Earth's atmosphere is the weird one. And then one of the big, most important things volcanoes put out are tons and tons and tons of carbon dioxide gas. Lots of CO2. That's mostly what the atmosphere of Venus is made of. Huge quantities of carbon dioxide. Where did our carbon dioxide go? We have only tiny, tiny little trace of it. Less than 1% of the Earth's atmosphere is carbon dioxide. The reason why is because carbon dioxide loves to react with liquid water. If you have things like liquid water around, like maybe, theoretically say an ocean, then what's going to happen is that ocean and the waves and stuff will just love to dissolve that carbon dioxide. And then once it's in the ocean, a bunch of complex chemistry happens and it makes these carbonate rocks at the base of the ocean called stuff like limestone. Carbon dioxide dissolves in liquids. That's how we make Coca-Cola fizzy. It has carbon dioxide bubbles in there. So the Earth is weird. So basically what happens is CO2 dissolves in oceans, and then over many thousands of millions of years, basically oceans are constantly acting to suck the carbon dioxide out of the atmosphere and then lock it up in the rocks in the Earth's crust. And then, over time, the crust can subduct and then, be remelted and the volcanoes can spit it again. And you can get a carbon cycle sort of thing going on there. But the main thing is, since we have lots of liquid water, that sucks the carbon dioxide out of our atmosphere. And then that keeps us a very nice, thin, normal sort of atmosphere. And then, other things get reprocessed. Venus was closer to the sun, just a smidgen closer to the sun. So as a result, Venus, since it's closer to the sun, it didn't have the liquid water that the Earth did. And so it didn't have anything to suck up that carbon dioxide, so it just built up a thicker and thicker and thicker layer of carbon dioxide. And so that's why its atmosphere is 95 times thicker than ours and why it's not a pleasant place to visit.